Good afternoon, everyone. My name is Wieke. I work for Nikon, the Japanese company in the industrial metrology product group. I will use the coming 10 minutes to talk about high-speed CT tomography by keeping the quality inside of the data. So, as mentioned, I work for the industrial metrology business unit. Since 2009, we are part of Nikon. Before, we were a spin-off of the university in Leuven, and Nikon kept the European headquarters in the same offices, so we are still located in Leuven in Belgium. We have the following products in our portfolio. So the measuring microscopes and vision systems. For Switzerland, there our partner RIF AG is responsible for the sales of those products. They are also having a booth, and you can find them in Hall 2. And then we have 3D solutions, so the laser scanners. So those are high-distance, non-contact laser scanners to scan big parts like satellites or airplanes. And then the parts or the products I'm going to talk about are the X-ray and CT solutions, so the one you can find over there, where we use Röntgen to get a digital copy and full insight into your part. So what does CT or X-ray inspection bring you? So actually, it's a solution where we will put a part into a system or multiple parts. We will switch the X-rays on, and while the part is rotating, we will collect 2D X-ray images, the same as what is used in the hospital if you have a fracture in your bone. In the end, you get a digital copy of your part, so that's the second you see over there, and it contains all information. So you have all surfaces, you have all internal features that you can use for dimensional inspection. You can compare with a reference part, so golden sample, you compare with a CAD file. And as you have so much information, it's easy to do the interpretation. So for example, on the part you see here, blue means that there is not enough material, red is too much material, so it can give you information on the deformation on the part or misalignments and so on. You can do full GD&T and dimensional inspection on the scan data, and also all crack and porosity information is there and can be automatically inspected and qualified. It's non-destructive, so you don't have to destroy your part, and you can virtually slice through it. The example you see here is a single component, but we can also inspect assemblies, for example. It's high accurate. We can, with the same system, adapt our scan process to follow the tolerances on the part, and you have the inside and outside information on your sample. If we talk about using CT into production, the fact that you have so much information in a short time allows our customers to bring in the technology early in the process. So it's not just an inspection tool that is at the end of the line. When the part is completely finished, you're going to check if it's right or wrong. But it's actually a tool that is used in all the different steps. The amount of information we provide make it easy to make conclusions, to follow up on deviations. So the moment the process starts to slip, you can already identify it and intervene. And you can combine information from our system with then information from the production systems, for example. So now you have a bit of an understanding of the solution itself and how it's typically used into a production environment. I will briefly touch and use the last 5 minutes to discuss our solutions for high-speed, high-quality CT. So in all our processes, we will start from your applications, your requirements, your budgets, amount of samples to scan. We will then test together and work with one of the sources that we produce ourselves to select the right one. If we look at sources that are relevant for the inspection of plastic parts, then we are in the 180 to 5 kV range. There we have a solution where the target will rotate, so it's easy to cool down, so we can create a lot more flux, speed up the scan process, and still keep the spot size, so the sharpness in the images. We also have a lot of special scan and reconstruction algorithms. And if we look at where CT developed in the last years, there were, of course, hardware developments that make an impact, but a lot was on the software side. So special scan techniques depending on difficult geometry, but also special reconstruction algorithms. Some solutions we have there is dual material CT. So typically, if you have a metal and plastic combined, it's quite challenging for a Röntgen, and you have to find a compromise. So there, that's a smart reconstruction technique that will take away some of the artifacts that you will get. Half-turn CT is a method to only rotate 180 degrees and a little bit more to speed up the process. So again, in almost half of the time, you can get approximately the same quality of results and have a full 3D copy of your part. And then another one is using AI. We don't use it in the analysis of the data, but we use it in the reconstruction. So we will create a model of the part, and that model will allow us to remove artifacts that you typically get when you are going to scan a few minutes, and then try to get the same quality of a 20 minutes, 30-minute scan in those very fast scans. And then we actually put that configuration together with a high-resolution detector in one of our cabinet solutions. So the result is a standard system, but we have the flexibility to configure it to your needs. If we look at another trend of CT in production, it's the automation aspect. So the moment you go to cycle times of a few minutes, you don't want your operator to be there and every time load parts. So we can cover that by having a fixture with a lot of samples and then batch scanning. So that's standard included in our system, so that automation part is there. We can go to semi-automated, I will come back to that later, or then full next to the line inspection. So semi-automated is a rack of samples you put in the system, and everything is programmed and will run automatically. So that can be a solution if you have multiple injection molding systems where every 2 hours you collect parts of. You put them in the fixture. One fixture corresponds one mold. You prepare it in the rack, and then an operator has to load the rack every 30 minutes, for example, and then another batch is launched. But we can go as far as full automation. So for some applications, the customer really doesn't want an operator to intervene, and then our systems can be communicating with a robot. We have the fast closing doors, and everything, including the X-ray sources, is designed and tested to run 24/7, so in full 3-shift production. An example that I'll quickly go through is indeed a customer using connectors for the automotive industry. It's not the correct part due to confidentiality reasons, but there actually the customer collects the parts coming from the injection molding systems. They are put into the rack. Then with the barcode, actually the macros are linked to the fixtures. Everything is put inside of the system and runs automatically. So in the end, the customer does a comparison with the golden sample, so to see if there are not too much deviations on a 3D level, and also measures the most critical dimensions to monitor the deviation in the process. And this scan time takes 6 minutes, and we scan 4 to 6 cavities in one fixture. I just used my 10 minutes. I tried to give you the overview, and I'm here all week. So we are standing in Hall 2 in the bottom right corner. So if you want to discuss something more into detail or dig deeper into something I briefly mentioned, feel free to pass by, and I'll be happy to further discuss. Thank you very much.